this is Mr. Kenzie's review for integrated algebra, day 19. We're going to talk about the quadratic formula as well as imaginary numbers today. So looking at number 1, it says, solve using the quadratic formula, round to the nearest tenth. So when I'm using the quadratic formula, we have to set it equal to 0. So what I'm going to do is I'm going to subtract the 4x and subtract the 2, because once again, I like dealing with a positive a value. You can just move that to the right, completely up to you. So when I do this, I will have 5x squared minus 4x minus 2 is equal to 0. I know that once that happens, I can state my a, b, and c values. The a is the number in front of x squared, which is 5. The b is the number in front of x, which is negative 4. And our c is negative 2. Our quadratic formula is x is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. So I have x is equal to our b value, which is a negative 4. So I'm going to plug that in here as well. So negative 4 squared minus 4 times a, which is 5, times c, which is negative 2. Make sure all of your values are plugged in with the correct signs. 2 times a, which is 5. I'm just going to go back and just check. My b value is negative 4. My a value is 5. And my c value is negative 2. So now we're going to simplify this. The outside is the easiest. So negative of a negative is 4. 2 times 5 is 10. Now we're going to simplify the inside. You can use your calculator. When you use your calculator, you're going to want to plug this in without the radical. So I'm going to plug it in exactly as I see it. So I have negative 4, close parentheses, squared minus 4 times 5 times the negative 2. Just like that. Push enter, you get 56. So I'm going to put 56 inside here as the radicand. So now I'm going to go up here as I'm running out of room. I need factors of 56. One, that's a perfect square. 56 is not a perfect square. So I have 4 plus or minus. So what you can do, once again, is use your calculator. Now go to y equals and type in 56 divided by x. Second graph, and look at the table. Now we need values that have a perfect square. Well, I have 2 times 28. That's not a perfect square. I have 4 times 14. 4 is a perfect square, so that's what we're going to use. So I have 4 times 14 all over 10. Now, the 4 is a perfect square that comes outside as a 2. So I have x is equal to 4 plus or minus 2 radical 14 over 10. One more thing that I am going to be doing is I am going to simplify this completely. Even though the directions say round to the nearest tenth, we'll do that last. So here, to simplify, I have 4 over 10 plus or minus 2 radical 14 over 10. Now I can simplify 4 over 10. Those are both divisible by 2. 4 divided by 2 is 2. 10 divided by 2 is 5. Plus or minus 2 over 10. Well, 2 divided by 2 is 1. And 10 divided by 2 is 5. So you could leave your answer like that. But this says nearest tenth. So actually, if you did for this specific one, you would lose a point. That's where your answer is going to look similar to the next one, though, because it just says in simplest radical form. So I'm going to go up here, and I'm going to show how to plug this in our calculator. You're going to plug this in 2 ways. So I have x is equal to, I have 2 over 5 plus radical 14 over 5. And I have x is equal to 2 over 5 minus radical 14 over 5. In your calculator, you're going to plug each of these in. And I'm just going to put each of these inside its own set of parentheses. So when I go to my calculator, once again, we're rounding to the nearest tenth. I go to my calculator, and I'm going to plug in parenthesis, 2 divided by 5, close parentheses, plus radical 14 arrow over, make sure there's no radical, divided by 5. Okay. So I push enter. Now I'm rounding to the nearest tenth. So that would be x is equal to 1.1. Now I'm going to do the same thing, but now I'm going to subtract. So I just do second, enter, and whatever I most recently plugged in will show up. And I'm just going to change this to subtraction. So now at the nearest tenth, that would be negative 0.3. So what this means, those are my two solutions. If I had a graph, and this is kind of like a check, and I'll show it on the calculator. So if I had a quick sketch of my axes I was going to graph, I would have a parabola that crosses by 1.1, so in between 1 and 2, so maybe there, and one that's negative 0.3, so about a third of the way here. So you would have a parabola that would look kind of like this. That's a very rough sketch. I will show it on the calculator. So y equals, and plug in the equation when it's set equal to 0. So 5x squared minus 4x minus 2. If I graph this, now my window's a little bit off. If I just push zoom standard, this is probably what your graph would look like. So once again, quick sketch of that. Number 2, you're going to be solving on your own, quadratic formula, except you're going to leave in simplest radical form. So like I said, like this. This is simplest radical form. That's why we did that. You won't be rounding. Next, we're going to talk about imaginary numbers. So imaginary numbers should be pretty fresh in your mind. We just worked with them a couple weeks ago. So we have, for this one, if I plug that in my calculator, I'll get an error because you can't have a negative radicand if you have an index. That's the number inside the check that is even, and our index would be 2 if there's nothing there. So I'm going to rewrite this as the square root of negative 1 times 441. The square root of negative 1 comes outside as an I. 441, if I go to my calculator and just take the square root of that, I'll get 21. So that's a perfect square. So my answer is 21i. You're going to do the same thing with this one, except then you're going to multiply by 2. We're going to move on to this. Now you actually can use your calculator for this.